Well, hello everyone. This is a part 2 of building the ground solar array. As you can see, my site has been cleared of all the debris, has been graded to my liking, and just a short show of what does it look like at this point. The other part of this clip will be a little flyover over the area there will house the solar panel array. You can see red marks down on the ground, and let's continue with discussing choices. After taking in consideration, and first of all, I apologize for this microphone quality. There's nothing I can do about it. This is the first time I'm using this. I'm probably going to use something else next time to achieve the better audio. What we're looking at right now is a PV watts calculator. This is from pvwatts.nrel.gov website. I have inputted my DC system size, my module type, array type, calculated system losses, tilt of 30 degrees, and azimuth of 210 degrees. Choice on tilt. When I choose 30-degree tilt, it gives the best possible production per year. When we go to the next section of this in the results, putting 25 or putting 35 produces the solar array would produce lesser amounts of energy per year. Okay, an azimuth is 210 degrees. I cannot have it pointing at 185 degrees south. That is adjusted for declination in this area. I cannot achieve that. The whole yard would look weird. I tried. He's just saying it's not going to work out. So let's go to the results. Okay, here we are on the results page. According to this, it gives you an estimate of production per month of each year. As you can see on the screen over here, the numbers extrapolated for my location says that I can produce around 1.8 megawatts of power per year, and it gives a breakdown for every month. This is all adjusted for my azimuth and for my location with a tilt of 30 degrees. Upon putting this number in, I decided to search for what would be the best ground mount solar array, and this is what I came up with. I decided to go with Iron Ridge, and I have used their design tool to help with my project. I selected the ground mount, and you type in your address and you go from there. This is what I have come up when using their design tool. This is the PDF produced by their design tool. Okay. When you input your numbers, of course, I have hidden my location and name and address and all that stuff. They will ask you to choose your modules. Okay, how many total watts, and then it gives you, of course, what date. I put in this date, but I have a previous dates too. ASCE code that stands for American Society of Civil Engineers, code 716. That's the one that is being used in the state of Georgia. This is where I started thinking first. Next thing they ask you to select in the first part of the design tool is a wind exposure. I chose B because I am in urban suburban area. That's what they tell you to choose for that, wooded areas and whatnot. They give you this option based on your address. Now wind speed, they picked a wind speed of 100 miles an hour. I have chose to go with a wind speed of 110 miles per hour and a snow load of 10 pounds per square foot. Now, why I did that? Well, here's a couple of things that I took a look at. I went to the UpCodes viewer, and this is for Georgia, and this is for a building code 2018. And here we see I'm on a map for a snow loads. State of Georgia, South Georgia goes with a 0 pounds per square inch when applying to buildings and structures. Central Georgia is 5 pounds per square foot, and that includes the Gwinnett County where I'm at. However, I decided to go with 10 pounds per square foot load. Okay. Next thing that I took into my consideration is a wind load. Now, when you go through a wind load, you can read all of this, and you will find a little map down on the bottom that gives you choices for the wind loads. As I said, their tool have selected 100 miles an hour. However, I went with this first map that gives you a little area where the 110 mile an hour winds are, which would be the south of this area, and then anything above this would be like 104 miles an hour. So for this area, even though it's per them it's 100 miles an hour, I select 110 just to be on the safe side. So with all that information in hand, we do get this. Okay, wind exposure B, wind speed 110 miles per hour, and a snow load of 10 pounds per square foot. Okay, now the little tool, which is nifty and very good, asks you to select, how many rows you want to have and how many columns. So I have a 14 columns, okay, and each column has 2 XR100 rails. So that's total of 28 rails. Each rail supports three rows of panels. Okay. By selecting that, it gave me everything else. It calculates everything for you, and then it gives you, how's it going to look on the ground, and your east-west pier spacing, and the north-south pier spacing. It gives you all the data, so you don't have to think about it too much and how you're going to do it. And also gives you other data as to how much total pipe length you're going to need. I went with a 3-inch schedule 40 pipe, and it tells me that I need 265 feet and 8 inches of it. So that will be the next process, is ordering that and getting it. Now, the total area that the solar array will take up looking from above will be around 700 and I think it's 760 square feet. We'll just round it up on that. Nifty little update, and we will go from here to the next design choices. And my next design choice is, how was I going to secure this into the ground? I have dug many holes and shoveled a bunch of concrete before, so I didn't really want to do that. So going through one of these, thinking what I can do, and scrolling through one of these documents they provide to you, you come up to this page where it says Build Base. And I found this, an American ground screw that can be used to secure your posts into the ground. So that's what I decided to go with. Why I decided to go with this, it's because I really, as I said before, do not want to deal with mixing concrete, digging holes, pouring concrete. That's just backbreaking. So over here, we can go to American Ground Screw website. After the conversation with Tom at American Ground Screw Supply and telling him what I'm doing, and providing him with the part number, we agreed on a price and shipping and renting of the tool. Tool is the one thing you have to rent from them because it's a fairly big and heavy machine that deals with putting this into the ground. So what they are sending me, and it should be here by Thursday morning, is this pallet with the tools and the ground screws. I'm supposed to receive this on Thursday midday or so. So this concludes this part of the video. Man, I feel crazy. Every time I talk in front of camera, I just can't get the words out of my mouth. But anyway, this is what I came up with in my design process over here. So maybe it can help you in designing your ground solar array. Thanks for watching, guys. There is more to come, especially when I start installing these screws into the ground. Talk to you all soon. Later.